When we think of stars, we typically envision tiny sparkling dots scattered across the night sky. This is the way we perceive them from Earth. However, stars such as Betelgeuse stand out dramatically. Betelgeuse in particular is so enormous that it dwarfs our Sun by comparison. This star has intrigued scientists for many years. Lately, however, new findings surrounding Betelgeuse have raised additional concerns among researchers. In this article, we will dive into the latest developments regarding Betelgeuse, including predictions from the James Webb Space Telescope about its eventual demise. We'll also examine how these events might impact our galaxy and life on Earth with insights from physicist Michio Kaku. Betelgeuse is a truly captivating cosmic mystery, a colossal star that has fascinated astronomers for decades. The first discovery of Betelgeuse was made by the ancient Greek astronomer Hipparchus. It is so large that it can be seen clearly with the naked eye, especially during the colder months. If you are an astronomy enthusiast, chances are you're familiar with it. Betelgeuse is the bright reddish-orange star marking the upper left shoulder of the Orion constellation. It is an ancient star and one of the brightest objects visible in the night sky. However, its brightness is not stable and fluctuates over time. This changing luminosity is one of the star's most captivating traits, but it is by no means the only remarkable characteristic. Most stars visible to the naked eye are located at immense distances from Earth. The nearest star to us, Proxima Centauri, lies 4.2 light-years away. To help put this distance into perspective, a light-year represents the distance light travels in 1 year at a speed of about 186,000 ms. In 1 year, light can travel billions of miles. Therefore, when we say Proxima Centauri is 4.2 light-years away, we are implying it is billions of miles from Earth. On the other hand, Betelgeuse is even farther away, located roughly 600 light-years from Earth. Reaching Betelgeuse at the speed of light would take an entire 600 years. Unfortunately, humanity is still far from being able to travel at light speed, even with the fastest spacecraft available. Despite this great distance, Betelgeuse shines brightly in our night sky. You might wonder how such a distant star can still be so luminous. The answer lies in Betelgeuse's extraordinary size and extreme brightness. Betelgeuse is approximately 500 times the size of our Sun, with a radius believed to be several times that of the Sun itself. When observed through advanced telescopes, Betelgeuse appears more like a disk rather than the typical point of light seen with most stars. This phenomenon is thought to be a result of the intense reactions occurring in its outer layers. In terms of mass, Betelgeuse weighs between 12 and 19 times the mass of the Sun. A single solar mass is equivalent to around 2*10 to the power of 30 kilograms, but astronomers can't measure Betelgeuse's mass precisely due to the lack of orbiting planets or objects that would allow direct measurement from Earth. The fact that Betelgeuse is many times more massive than the Sun makes it stand out. Its brightness fluctuates between a magnitude of +0 and +1.6, meaning it can be around 16,000 times brighter than the Sun, earning it the classification of a red giant. However, its luminosity isn't constant. It fluctuates because of internal pulsations within the star. When Betelgeuse expands, it becomes brighter, and when it contracts, it dims. These cycles can last from 10 to 100 days, or sometimes even longer. Another fascinating aspect of Betelgeuse is the existence of dark magnetic spots on its surface. These spots, where the magnetic field is much stronger than usual, prevent hot gases from flowing to the surface, causing those areas to cool. Betelgeuse has many more of these magnetic spots compared to our Sun, which is why it appears cooler despite its much larger size and brightness. Although our Sun also has dark magnetic spots, Betelgeuses are far larger and more numerous. Some of these spots can be twice as large as Earth. In fact, Betelgeuse has a magnetic field about 1,000 times more powerful than the Sun's. This magnetic field creates spiral or arc-like patterns on the star surface. When viewed through telescopes, the surface temperature of Betelgeuse is roughly 3,500 Kelvin, which contributes to its dim red glow. Interestingly, Betelgeuse wasn't always a red star. Around 100,000 years ago, it had a yellowish hue, similar to our Sun. Over time, it shifted to an orange and eventually red color. Around 10,000 years ago, Betelgeuse began its transformation into the red star we observe today. This led scientists to believe that Betelgeuse is in the process of aging. Betelgeuse emits up to 10,000 times more energy than the Sun. Had it been closer to Earth, it would outshine our Sun. If it were located even closer, it could potentially be visible during the day due to its immense size. If Betelgeuse replaced our Sun, it would engulf Earth and the nearby planets. Even if Betelgeuse emitted the same energy as the Sun, it would still radiate far more power, making it even more formidable. Despite being located 600 light-years away, Betelgeuse is still visible to the naked eye. A remarkable feat. Sun, by contrast, is only 8.3 light-minutes away, but it is much brighter due to its proximity. Betelgeuse ranks among the largest stars known to us, with a size approximately 500 times that of the Sun. If it were placed at the center of our solar system, it would easily encompass the orbit of Jupiter. This immense size causes Betelgeuse to appear as a disk when viewed through powerful telescopes, unlike most other stars which appear as small dots of light. While Betelgeuse may not be the most massive star in the universe, its mass is between 12 and 19 times that of the Sun, depending on varying estimates. One of the most intriguing aspects of Betelgeuse is its variability in brightness. Unlike our Sun, which remains relatively constant, Betelgeuse experiences irregular fluctuations in luminosity. At its brightest, it is 16,000 times more luminous than the Sun, but during its dimming periods, its brightness can decrease significantly. These variations have fascinated astronomers for centuries and provide valuable insights into the star's life cycle and characteristics. The surface temperature of Betelgeuse is relatively low for a star of its size, around 3,500 Kelvin, giving it its characteristic reddish-orange hue. As a red giant nearing the end of its life, Betelgeuse has depleted its hydrogen fuel and is now fusing heavier elements. This fusion generates energy and causes the star to expand. Its surface is also marked by dark magnetic spots far larger than those on the Sun, which restrict the flow of hot gases to the surface, leading to cooler regions. Betelgeuse has long been studied by astronomers with various cultures, including the Greeks, Egyptians, and Chinese, documenting its position and brightness. In Arabic cosmology, it is referred to as Yad al-Jaza, meaning the hand of the giant. Recently, Betelgeuse has gained even more attention due to a series of dimming events that began in late 2019 and continued through mid-2021. During these events, the star's brightness dropped to unprecedented levels, sparking speculation that Betelgeuse might be nearing the end of its life and possibly going supernova. A supernova is an explosive event that occurs when a massive star runs out of fuel and collapses under its gravity, triggering a massive explosion. If Betelgeuse were to explode as a supernova, it would become one of the brightest objects in the sky, visible even during the day. The idea of Betelgeuse going supernova has captured the imagination of both scientists and the public. Astronomers continue to Monitor the star using advanced telescopes and space-based observatories. To better understand its behavior and evolution. Betelgeuse's status as a red supergiant offers important insights into the later stages of stellar evolution. These stages involve the fusion of heavier elements in the star's core and the subsequent dispersal of these elements into the interstellar medium. Studying Betelgeuse helps astronomers understand the complex processes that shape the universe. When we look up at the night sky, we often see stars as small distant points of light. However, stars like Betelgeuse located in the Orion constellation are far more than that. They are some of the largest and most well-known stars visible from Earth, and their stories are filled with cosmic drama. Betelgeuse, situated around 600 light-years away from Earth, is a red supergiant star in the final stages of its life cycle. Its diameter is estimated to be 500 times greater than that of the Sun. If placed in the center of our solar system, it would extend beyond the orbit of Jupiter, dwarfing our Sun. Despite its massive size, Betelgeuse's brightness fluctuates dramatically. At its peak, it is 16,000 times more luminous than the Sun, but it can also dim considerably. The dimming observed in late 2019 sparked widespread interest in whether Betelgeuse might be preparing to explode into a supernova. Although Betelgeuse's behavior has intrigued astronomers for many years, the dimming in 2019 and 2020 was unprecedented, making it one of the dimmest stars in the Orion constellation. Some believe the dimming could signal an impending supernova, but recent studies suggest it was more likely caused by a dust cloud forming around the star. Betelgeuse regularly expels material, and occasionally this material clumps together to form dust clouds that obscure the star, reducing its brightness. While the dimming cloud temporarily lowered Betelgeuse's brightness, the star itself remains active, and there is no direct evidence to suggest it is on the verge of exploding. To fully understand Betelgeuse's significance, we must delve into its life cycle. Like all stars, Betelgeuse began its life in a molecular cloud of gas and dust. For most of its life, it fused hydrogen into helium, much like our Sun. However, because Betelgeuse is much more massive than the Sun, it has exhausted its hydrogen fuel and is now fusing heavier elements like carbon and oxygen. This fusion process generates more energy, causes the star to expand and evolve into a red supergiant. Stars like Betelgeuse end their lives in dramatic supernova explosions when they can no longer sustain fusion in their core. Gravity causes the star to collapse, triggering a massive explosion that can outshine an entire galaxy for a short period. If Betelgeuse were to go supernova, it would be visible during the day despite being 600 light-years away. The explosion would scatter elements such as iron, calcium, and oxygen into space, enriching the interstellar medium and facilitating the formation of new stars and planets. Supernova play a crucial role in creating the elements that form planets, including Earth. After a supernova, the star's outer layers are expelled and its core may collapse into a neutron star, or if massive enough, a black hole. While Betelgeuse's eventual supernova will be a spectacular event, there is no immediate cause for concern. The explosion is expected to occur within the next 100,000 years, which means it won't affect us anytime soon. Even if it were to explode tomorrow, the immense distance between Earth and Betelgeuse means its explosive energy wouldn't reach us in a harmful way. Betelgeuse's future supernova, while fascinating, will not have any immediate impact on Earth. The 600 light-year distance ensures that the explosion would not harm our planet. Nevertheless, it highlights the immense power and dynamism of stars like Betelgeuse and the role their life cycles play in the ongoing evolution of the universe, the eventual explosion of Betelgeuse into a supernova will be a momentous event for astronomers and anyone fortunate enough to witness it while still a long way off. This event will be a crucial milestone in our understanding of stellar life cycles. For now, we can continue to marvel at Betelgeuse variability, its colossal size, and its significant role in the grand story of the universe. Stars like Betelgeuse remind us that the universe is constantly in motion, with change and mystery unfolding across vast distances. Studying these incredible stars not only fascinates us with their beauty and power, but also deepens our comprehension of the forces shaping the universe and everything within it. The study of stars like Betelgeuse gives us valuable insights into how the universe works. The immense size and fluctuating brightness of Betelgeuse provide astronomers with clues about stellar life cycles. As it is nearing the end of its own, these stars go through massive transformations, especially as they expand into red supergiants, and Betelgeuse is no exception as it ages. It's burning through heavier elements in its core, eventually preparing for the violent and awe-inspiring end that will be its supernova. Betelgeuse's eventual supernova will not only be a spectacular show but also a momentous event for scientists. It will help them learn more about the life cycle of stars, especially how massive stars enrich the interstellar medium by spreading heavy elements across the cosmos. These elements contribute to the creation of new stars, planets, and potentially life itself. The fact that Betelgeuse's explosion will happen in the distant future means that we have some time to observe and analyze this process. While the supernova itself won't affect Earth directly due to the 600 light-year distance, it will be a beacon in the sky for astronomers to study and learn from. In fact, the explosion will allow them to understand more about the role of supernova in the evolution of galaxies and planetary systems, as well as the formation of the elements that make up the planets in our solar system, including our own Earth. Even though we won't witness this cosmic event for many thousands of years, Betelgeuse already provides valuable lessons about the nature of stars, their life cycles, and the broader processes of cosmic evolution. As we continue to monitor Betelgeuse with powerful telescopes and space-based observatories, we will gain deeper insights into the dynamic nature of the universe, both now and in the distant future. Betelgeuse's life and death will leave an unforgettable mark on our understanding of the cosmos, continuing to captivate humanity's curiosity about the stars above and how they shape the universe around us. Whether you're an avid astronomy enthusiast or just someone fascinated by the mysteries of the universe, Betelgeuse's eventual supernova will be a reminder that the cosmos is always changing, and that in the grand story of our universe nothing is ever truly static.